All right, I think, good to start now. So thank you all for joining here today's session on the Collaboration Summit. So as more people are joining, let me already go a bit over the logistics here of the next 2 hours. So with me, I have a couple of colleagues I'll introduce while we are in the session. So we have 3 parts. I will start with kicking off this today. Let me also share my video that you have this more interactive. So thanks. So sorry, I appear a bit dark, but my camera will focus in a moment. So my colleague Mugove is also on there.
Yeah, hello everyone.
So we can keep this interactive here as well. So I see if some other people are joining with camera, feel free to do so. We have later Siegfried from my team as well on there, and later then we have Samir also joining us here. So let me talk a bit about the use cases here. So first, I have called the slide before COVID-19. So many of us were basically in their office in a physical building. So a few people working remote. Depending a bit on the company you work with, you were already remote before, but especially here in Germany, I have to say we have a lot of customers and partners we work with that are more focused to office, especially if they're coming from the government area or working in some finance type of industry where it's really important that they don't have remote access into their data center, so to say. So everything is more like an on-prem type of infrastructure. But with Microsoft 365 being part of that, it's kind of opening up. And now with Teams, obviously, it has opened much up broader. And what has actually happened is, like I put it up, second slide up here. So in the actual office, so only a very few are left in the office. So if you're working from the office, feel free to drop a line. So for those working in your home office, feel free also to drop us the line into chat just to get a bit of conversation here of if you are more like a person like today working from home, or if you're working from the office. So ideally, we would be all sitting in one big conference room now and have a session in there and talk a bit through the development mechanisms that can be used for Microsoft 365. But this is the state. So when we take this into account today, so and talking about monitoring, I picked a few services, and the service I picked today is Microsoft Teams. So in the Microsoft Teams environment, obviously we have a lot of components that are key to monitor and make sure that they work. So as this is a service, obviously we come to a point where you are not really in charge of your infrastructure. As you know, Teams is running on Microsoft data centers, so there's limited possibilities we can retrieve logs or other information from the operations or the systems or the applications that are running within Microsoft. So if you are the administrator of the Teams infrastructure, or if you're a user, you might know how Microsoft publishes information on if Teams is working or not. And I give you some examples that where problems occurred in the last months. So the challenges we have here today is really that eventually there's a service interruption or a service problem reported. But due to the nature of Teams, which lives in your tenant, you're not really sure if you are affected or not. So the big question typically is are my users really affected? So if you're working on your Teams environment, there are multiple issues. For example, there's a probability that we can use or share our screens, so which is a problem on their infrastructure then. Or we might have a problem that we cannot remote control through a team session, other sessions. So that was actually a problem that occurred like 2 weeks ago and was there like for over a day, where it was simply not possible to controls another sessional. And in this case, obviously, you might call your help desk, but your help desk is kind of helpless. They cannot do except looking at the status of the environment and see that there's a problem. However, there are a couple of other problems that might well relate to your IT infrastructure. For example, if you have an internet service provider and you're going to the internet and your internet service provider has a problem, somebody in front of your house digs up the cables and interrupts your connection, and you might you have a problem. You will probably very soon notice that, and that might be quite obvious, but that's on your side, and you have to troubleshoot that with your service provider. So that is like one thing that moves more to the home office space. But one thing which might be more challenging is, for example, if you're using like a hybrid architecture for your authentication. So if you, for example, need to log on with a username and password and use a MFA token, and at that point in time, you still have, or your company use an ADF infrastructure that passes through the authentication to an on-prem AD to verify your access. So in this case, if you don't have an active token, you might not be able to actually log on. And this is a problem that's neither on your side nor on Microsoft's side. So on your side, I mean in your home office in that case, but it's something that, for example, can happen on the company infrastructure side, because the token request that you issue on Microsoft is passed through to your premises infrastructure and then comes back with an alert. So there are just there's a number of problems that might occur, and for this, we've been developing an application, and we'll walk a bit through in the next hour about how we develop this application, or what things we have to take into consideration if, in general, you develop an application for Microsoft 365, either for any collaboration need or for monitoring needs, anything you can do with Microsoft 365 as a service. And I will just quickly show now the application, just that you get like a front end view from it. And so I will just open my demo system for that. So just have to find it. Here we go. So this is basically an HTML5 web page, a status board, so to say. And in the back end, we have an application which does work with Microsoft Teams, with Microsoft Exchange, with various Microsoft 365 services, and tries to understand if everything is healthy. So we can, for example, have a look at Teams, so which we just talked about. So we have a number of Teams tenant, and we also have like availability information for each of those, and also like service information, like if chat is working fine, and other performance data. The same we have for example, for Exchange Online or other services, which give us information on mailboxes, mail flow latency, but really mailbox logon checks of an end user, so that it has this end user view on that. I wanted to just show you this quickly. This is a dashboard, and we come in the last section again back to that dashboards, and in those dashboards we'll have a bit more insight. That is provided by a company called Squared Up, and we are basically talking today about the application that delivers the data here. And this application is a true Microsoft 365 application. So let's just go back to the slides. Go. So, all right. So we have on the left side the Microsoft 365 services, and in the Microsoft 365 services are Teams, SharePoint, and we'll look at various of them. So, and then we have like a virtual machine that could basically run on every point, and we have basically a .NET application. So we are working everything really a bit around .NET here. So, and using the APIs that I'll talk in a moment about. So, and let me just get the pointer here. So this is the Active 365 monitor. So, and that's what we will be talking about, plus a little bit about another application that will upload like monitor data to Azure Monitor or another monitoring solution like Microsoft System Center. So data that is being collected about your Microsoft 365 services then provided external to other sources where it can be, for example, presented like in this dashboard you have been just seen. So the idea is really today to dig a bit into the area, like how do we develop an application to consume services and APIs of Microsoft 365. So that's the key area what we're talking about. And when we look into that, we'll touch quite a number of different items, like, for example, the Microsoft Graph API. We'll talk about application insights, metrics. Then we can go over the Query language, like to take data out of Azure Monitor, and we could use webhooks or as well the Azure VM. So we will go into like an interactive Q&A session now, and I have two of my colleagues with me here today. So Siegfried, do you want to quickly say hi and introduce yourself and just give some background what you do at NiCE with respect to development?
Okay, hi then. My name is Siegfried. I'm came from development, and currently I'm trying to get an overview, to maintain an overview of the development of all our products from a more high-level perspective. And I will be starting then this diving into the API pool session with two questions. For a more detailed discussion then, or presentation of the APIs we are using, I'll switch over to my colleague Mogobe. Mogobe, do you want to say hi? And unmute your phone.
Hi, everybody.
Okay.
Yeah. That's a good part. If you have video, you see actually that somebody speaks, and you don't hear something, so you can just say right away that your microphone is off. Okay, cool. Go ahead.
Once again, thanks for introducing me. My name is Mugobe Kangai. I'm a software developer at NiCE. So I work on developing management packs, such as for Teams in our product Active 365.
Great. So perfect. So thanks for the introduction. So, and with that, I'll actually we'll go already to the first question and switch over to my colleague. So in the first question really is, and stop my presentation so Siegfried can take over. So I really asked her, like, what does application development mean in the context of Microsoft 365? So what does it mean when you develop an application? So Siegfried, please.
Okay. Basically, it means that you extend the Microsoft services and clients. So there are multiple types of applications or integration points in which you can integrate or in which you can extend the Microsoft 365 services and clients. For example, some of them are less tier teams, which we have covered a little bit more in detail on the next slide. The Office applications, which you know, SharePoint, which you might know. And even you may develop such applications which you have seen on the slides which Christian presented just a few minutes before. Our collectors, for example, the collectors which collect data from Microsoft 365 services and evaluate them, check them, and eventually feed them into a console or in for example, the SCOM or which are then used to present and evaluate these whole things, for example, on a central console. So what you have here is a cloud service is your target. You don't have this more traditional thing of attaching to an application, monitoring to an application, or extending application by running on the same environment or running on the same system, which the application itself, by using their DLLs, for example, anything like that. You have to use APIs and SDKs to communicate via the network with the service, because the service is running in the cloud. You don't know where it is, and you cannot just check their log files or attach to processes or using any of the traditional means of, for example, monitoring or extending these programs. So you have to use their APIs and their SDKs to communicate. And this is what limits you in your in the possibilities, in your in the way you are checking or retrieving data, and at all which data you can retrieve. That's all restricted or limited, controlled by the API. Moreover, the API will control your requests in a way to the service. So just to save the service, to guard the service from, for example, high volume requests. So there will be kind of throttling, and your application will have to deal with that. For your application, yeah, Christian, you wanted to ask something? No,
all good.
I just saw it on the screen. For your application, you have various programming languages and platforms supported. So just a few of them are listed here. So anything you can imagine would be supported by the APIs. There's a plethora of platforms and languages. Sometimes the language or your type of application then determines the language. And sometimes you can choose the language that you will. And in addition, for the application development, there's a developer platform available. So you can register with Microsoft and get a development environment, a development tenant. So just to try out your applications in a real environment with a real service. I just think that it's still at no cost. So you just have to register then, and you get the test service, or a tenant in this for the service, just for free to apply your tests against it. So mentioning Teams, these are a couple of Teams apps. You might have seen them when opening your Teams client and tapping on the apps tab then here. These are integrations into Teams. They integrate with the Teams apps. You can control them, these apps, via the Teams apps. And there are some or different types of integrations or of Teams apps here. You can have just connectors which connect to another application, fetch the information from them. You may have chatbots, with which you can communicate via chat, and then they go out and control other services, fetch the information from other services, or just start other services, which then will get or proceed with the desired information. So you can get notifications into Teams. For example, you can have a Jenkins notifier, then just by installing a plugin in Jenkins, you can get the information then from your builds and from the statuses, from the changes, right into your Teams app, into a channel, so that it's all visible to your developers then, and all in one place. So Teams apps, various types are then here possible. And these are then mainly controlled by the front end, the Teams front end, and are integrated into the Teams front end, but also maybe integrated into the Teams service as well.
Yeah, quick question. So there are a lot of apps on the screen. So, and I've seen them before. Are they free or are they cost? When I select them, do you know that?
I don't know exactly. For most of them, which I've seen, were free. It might be that some of them have bring a cost with them. You might license something. So I think it depends.
Okay. Thank you.
So the next thing then would be which application types are possible with Microsoft or as a Microsoft 365 application. So we have seen the Teams apps here, which are more like the front end, in the front end category. as well as the Office add-ins, for example, or SharePoint add-ins, which are then distributed or running maybe in your browser, in your Teams client, or in the service as well. Just depends on the type of application you're creating. And there are backend services here. For example, I took here the direction of the communication as a differentiator here. For example, the agent, I called it agent. The agent connects to the Microsoft 365 services and conducting some create, read, update, and delete actions, for example. So this type of application would be used by our products then to connect to Microsoft 365 and fetch data from them, which is then monitored and further evaluated, controlled, checked by our products. So the agent is the active part, connects to the service, then gets data from the service, and which is used in our situation or in our products for monitoring. Other products could as well using the create and update and delete actions then, which are possible in the APIs, which this agent is using to connect to Microsoft 365. So our products are still monitoring, fetching the data, but there might be products or agents or apps then which connect to Microsoft 365, which control various aspects of the service. And it all depends on the API, which is provided by Microsoft. So you can only get the information and you can only control the information which you are allowed to, which the API makes available to you. As an other type of application, there might be a kind of service you are creating. With service, I mean that the service must not be the first part which connects to actively connects to Microsoft 365, but is notified by Microsoft 365 when something happens in the service in which you expressed interest. For example, you might define webhooks which are executed by Microsoft 365 when, for example, certain Teams events occur. For example, if call records are available for a meeting or for a call which you conducted over Teams. So you might get as well be notified, contacted by Microsoft 365 services, and then you might execute other APIs to get the information which was announced by this notification. So this is called a webhook. For this, of course, your service must be available or connectable by Microsoft. So it needs to be listening all the time, needs to be guarded then. It's running and connected from the outside of your premises. Speaking of premises, the application deployment here, on which environments might your application be deployed? Well, it depends on the target service you're monitoring, on the application type, on your architecture. Target service, for example, speaking here, client and browser, Teams apps or Office apps might be executing in the client or in a browser, which is used to connect to the service. Or if we are thinking on the other side of the slides, which we saw a few minutes ago, you have services or agents which are running on a VM. Might be on a VM in the cloud or on an on-prem VM. The architecture or the environment, the platform, simply doesn't matter. It's possible to have Linux and Windows systems as well. And even you might position or deploy your apps in a container running on Kubernetes or something else, or even serverless using Microsoft Functions, for example, to host your application and then to connect from there to the Microsoft service which you are targeting. So there are a couple of ways to deploy your application. It might depend on your target service, which you are trying to read or control. It might be depend on your application type and the architecture, but there are many ways then here to deploy the application. So not only simply as we've done in the past on a VM or on a server, on a data center on-prem, you might go as well in the cloud and use all the features which are now available there. So application deployment.
Wait, I have a follow-up question. If you can go just one slide earlier. Yes, when we talked about monitoring, so what would be the application type you would typically use for a monitoring application, like the data collection?
The agent then, as I've mentioned, because we need to be started on a regular basis, or are even kind of a long-running agent there, which runs in a loop and is controlled by the outside. But then the agent would be active and connect to the 365 services to get the information we need for monitoring a specific area, for example. So that would be the active part.
Mm-hmm. Okay. Great. Yes, understood. Yeah. So, like one other question, like for another use case, let's assume you mentioned that there's an integration for Jenkins for other systems. I think like for source control in the Teams apps. But let's imagine I would like to submit like a Jira ticket while writing in an email. What type of add-on could I imagine then when I do an email and I want to log it somewhere to? Where would I put that as an application type?
I think that application type would be more than of a connector type, which is possible, for example, in Teams as well, or in the Office as an Office add-in. Just then getting the email and parsing it, executing the actions, and then using the Jira API to open a Jira ticket then.
Mm. Okay, yeah, this is, I think, the most familiar Office add-ins I use every day when I, for example, schedule a Teams meeting. I typically click on Teams and then adds the Teams information. So just for me as like a non-developer here, so I would, this just for my understanding, this is like the Office add-in, correct?
Yeah,
okay.
Would be something like that, yeah.
Okay.
So we saw that for monitoring and for controlling certain areas of the service, and even everything needs to be conveyed to the service via an API, and the SDKs are take it simply code around the API so that you are not forced to use this boilerplate code or write this boilerplate code, which does preparing the requests, executing the requests, checking the responses then, and also on. So these SDKs then are more a little bit higher on the abstraction level, but basically they use the APIs which are provided by the service, for example, REST API or Graph API or something. But I think, Mugove, you have more information on this topic.
What are the key APIs and SDKs that are available? So if you want to go ahead now and develop an application, so what you should take into consideration, what to look for. So Mugove.
Right.
It comes up. Yeah, there we go.
Super.
Thank you.
Super. So as Siegfried mentioned, there's several resources that you can consume on the Microsoft Graph API, depending on what you want to achieve. As the Graph API is a collection of resources that are provided by Microsoft to help to provide access to several applications in the cloud. So whether it be your mail, whether it be your SharePoint, your Teams, it's a set of rich APIs that are available. And to facilitate this, the Microsoft provides what they call the Graph API. And To access it, you can go to this link here, developer.microsoft.com/graph. And on this website, it's a graphical website where you can actually test out various links, for example, SharePoint or Teams or OneDrive. So let me just start up my screen here. So we have
wait, Mugove, we don't see that. We just see your slides still.
I just only see my slides.
Yes, and I really like to see that graph endpoint explorer.
Right. Yeah. Okay. Just hang on.
It's a bit tricky with Teams because you kind of probably have to stop again. Yeah, exactly.
Stop the presentation and then try and share the other screen. It's right.
We've got time, so no problem.
Okay.
So let's see. Yeah.
Hope you can see that now.
Yes, I see the. Yeah. Thanks.
So so if you go to developer.microsoft.com/graph, it will take you to this website, and it just gives you an overview of what's available in the Graph API. It tells you all the supported languages and platforms that are available. So you can see you can develop for Android, you can develop for websites with ASP.NET MVC, your iOS, for Java, JavaScript. Basically, it supports almost all platforms out there because it's a REST-based API. So they provide some, should I say, your DLLs, which make it easy for you to use in a language such as C# to consume these services. So to test out the APIs, you'd simply click on the Graph Explorer link, which is there, and it'll take you to a tool they provide, and then you can quickly see the services on the left, and then you can test them out. Now, obviously, if I was to sign into the Graph Explorer here, I would have to supply my credentials for a tenant. Now, before you can actually start using the Graph Explorer, you need to have a tenancy available. And to access a tenancy, you would first need to register on Microsoft.com and then register for your tenancy. And then you use those credentials to sign in here into the Graph Explorer. But what I will do now is I will not sign in. I will just show you how easy it is to go through the various services. So you have your getting started services to request information about your profile, get your photo, get your mail information. There's also various services like at the bottom, you've got your Microsoft Teams. So if you want to call a Microsoft Teams, you can. For example, you can request which teams are you joined to or which are members of a particular team. You can also post, which is basically send a post request to create a channel. Before then, you can actually send a message down the channel. So you can call all these endpoints through this Graph Explorer. There's also OneDrive. There's also SharePoint, and then there's also a list of various users. Now, to all these services, I won't go through all of them. I'll just show you one or two. Are protected by various permissions. So an AD, an administrator will have to has to provide a
Okay, so just let me recap. So I also opened this Graph Explorer here, and when I log in, I typically have my Teams credentials. So, and everybody, I think, who is on there has their team credentials. So that would be a Microsoft ID. That would be just possible to use, correct?
Correct.
Yeah.
Correct. Yeah. So
but when you say it needs different permissions, basically, so for your tenants, so might not all of them work. So somebody has to give permissions to use specific functions. This is what you're mentioning, correct?
Correct. So yeah, because all the yeah. So for example, if you want to use Teams to create a channel, it's your systems administrator has to actually provide you with the to provide global administrator privileges to allow you to access or to call this endpoint there, because otherwise, because these permissions are quite powerful, you could actually abuse this information or extract information which we might not want you to do. So these endpoints are protected by various permissions in a role-based access. So I'll start with this get my profile. Just click on it, and yeah, we just literally just run the query, and then it will just come back with the response preview to say, okay, my name is Megan Bowen, and this is my mail, this is my phone number, etc. Or I could run get my photo, and yeah, it will just come back with this information back to us in the response preview. So it's really simple to use by just calling this here being our endpoint. So the graph.microsoft.com, this is the version 1.0, which is the old or the currently used API version, which has the permissions, which I was talking about. So you've got your permissions, which you find here. So this endpoint doesn't really require many permissions, but when you access other endpoints, they will have permissions which are available, which you need to have before calling this endpoint with some information. Then we also will talk about the access tokens, because before you can query a Graph API, you need to supply an access token because it's protected. An access token is when you first log in, you connect to the Azure AD endpoint. At the Azure AD endpoint, you request an authorization code. So you sign in with your username and password, which connects you to the backend, and it returns you an access token and a refresh token. And these tokens are then what you will then use to connect to this endpoint here, to this endpoint, and basically retrieve the data. So a refresh token usually, so with your access token, it usually lasts for say about 30 minutes. And then when you want to connect to this service again, you would have to sign in again and sign in again and sign in again. But if you're creating an agent, as Siegfried mentioned, an agent which runs continuously to poll, you cannot have your administrator just continuously logging in every 30 minutes. So we would store the refresh token, which lasts a lot longer. And then when the access token expires, we would then connect to the Azure AD token endpoint to request for a new access token. So we use a refresh token to get a new access token when the access token has expired. And normally, if you look at the access token, okay. So if I have to sign into Graph Explorer to request an access token, we could actually view the access token to see what it contains, what details it contains. So I'll just do that. I'll just sign in. So we've got our access token here. And normally we encrypt this access token because if a hacker was to get a hold of this access token, they could use it to impersonate ourselves and request a bunch of information. So what I'll try and do here, so there's a tool that we use to just view the access token. Just hang on, so I'll just paste that in. And yeah, so with the access token, you can actually view the information that's available to you in the access token. So what we normally do is encrypt this access token using an encryption facility that's available to us. And this is one of the things that we do at NiCE. We encrypt the access token so that if a third-party user or a hacker was to get a hold of these access tokens, then they cannot actually use them without decrypting it. Right. So I'll just go back to the presentation. So I've just showed you the Graph API and all the purpose that it's a REST-based services that evolved out of ACS, and it provides a way for us to access several services in Microsoft 365, such as Teams, SharePoint, Excel, OneDrive, etc. Okay, we've noted that when we wish to consume a Microsoft 365 resource, we have to first connect to an endpoint. So we saw an endpoint such as the Me endpoint. The Me endpoint allows us to allows me to retrieve information about myself, whether it be my photo, my contacts. Yeah. Okay. Just hang on. Right, so people are having.
Wait, can you just make sure you're going back to the slides?
Sure.
From the sharing. Yeah.
Let me share that again. Just a moment. Just a moment. Right, can you see that?
Yes, there we are. Thanks.
Okay. Right, so let me just back this up a little. And yeah, so I was mentioning that we can connect to an endpoint, to a Graph API endpoint, such as the Me endpoint, or it be a Teams endpoint. And then we would first, we will need to sign in. So the pop-up will come up where you'd enter in your username and password to retrieve your refresh and your access tokens. And then with this refresh token, we'll then connect to our Graph API endpoint and use that to request a resource. And then we'll consume the data that comes back. And at the same time, we'll then store these refresh tokens and encrypt them for next use. So for you to connect to a Microsoft 365 endpoint, we need to create an application in the tenant. We'll need to create an application in the tenant. And what normally people use is a V1 app model. So a V1 app model requires you to specify the URL for the application where the application is hosted, or where Microsoft will send these access and refresh tokens to. So once you log in, it will redirect the user to this endpoint, and then they can continue their business of consuming this endpoint. But before they can do that, they have to register to say, these are the permissions that are available for use. These are the permissions which are available for use, and once the application is registered, the user cannot change these permissions, which is the drawback, because if you then add new features into your application, you'd have to actually recreate the app. And this can sometimes be difficult in situations where, say, you have a big bank and they have a protocol or a procedure in place where they should first request or formally kick off a formal process to change anything within the environment, whether it be requesting new permissions. This is a process they would have to go through, and it can be cumbersome and time-consuming. So a V1 app model is not as easy to upgrade with new features. So there's this new V2 app model, which allows the permissions to grow as the application grows, as the developers add more features, which is the direction in which the Microsoft Graph API is evolving towards. But this is still a new feature. What is currently in place and what is more mature is the V1 app model, which is in place. Then there's this whole talk of delegated application permissions and application permissions. So delegated permissions is also a concept that a developer of a Graph API has to be aware of, because with these delegated permissions, the application is using the user's own credentials to request for a resource. Say you want to request, going back to that me endpoint that I showed earlier. With the me endpoint, you'll be using your delegated permissions because those are your personal permissions. Those are for you. But say you want to access somebody else's information, such as maybe somebody else's calendar information, then I might not use my credentials. Rather, I would use an application permissions credentials, which the global administrator would supply. So we've got these two concepts of delegated permissions and application permissions. Delegated is, say you want to issue a search criteria on some endpoint, and then you want to filter those results to cater for a specific user, then you would use delegated permissions. But if you want to use an application permissions, you want something that will constantly run in the background without any user input. Right, so again, we've got more information available on how to use these concepts in the Graph API. Right, so here I've got a simple workflow on how to actually retrieve information from the Graph API, which you have on the right here. You've got your Microsoft Graph API endpoint, which is ultimately the resource you want to request, whether it be SharePoint or OneDrive or Teams. And that's your Graph API endpoint. But before you can access this endpoint, you first have to go through this pattern where you have your native application. So if you want to store your refresh tokens for later reuse so that you don't have to constantly sign in and sign in again, you have to develop a native application, which is, when we say a native application, it means a program that has access to your hard drive and can encrypt the refresh token that it has retrieved from as your AD. why are we talking about Azure when we're supposed to be using Microsoft Graph? So Azure is where we connect to get to authenticate the user. You could also authenticate on the on premises, but usually you would first have to go to Azure AD, and then it will then redirect you to your authorization server. So the normal thing is the user would first try and sign in. So they would request an authentication code from Azure AD endpoint. So they'll get a pop-up and then they'll sign in, and then it will return the authorization code. And then once you have the authorization code, you then connect to the Azure AD token API endpoint to receive this access token and refresh token. And once that access token and refresh token has been supplied, we'll then send that access token to the Microsoft Graph API, and then it will return the data that we need. But and then we'll store the data and encrypt the access token and refresh token for next use. Now, we mentioned that the access token expires. So once the access token expires, we would not ask the user to sign in again, but we just call a method using the Microsoft services library to call this acquired token silent async. So we just send in the refresh token and it will send us back a new access token, which we then send to Graph API to say, please supply us with the graph. And that's it. So it's that's the pattern that all endpoints use. And that's it. So thank you very much.
Okay. I would just ask now my colleague Siegfried to also talk a bit about the security part of it and authentication and authorization and what it means, because we had the Graph Explorer and I pasted actually the link for everybody also in the chat. So I hope everybody can access that so that you can kind of try this out while you're at home, so to say. We mentioned briefly, or Mugova mentioned briefly, that there is everything about the permission sets, and obviously we didn't show yet how the permissions are granted or revoked in the actual service principal, or where the Graph API talks against. And Siegfried can show us this in a live environment for now. And maybe Siegfried, just over to you and give us some information, some background on how this looks in the Azure AD portal.
So I guess you want me to show something about security.
Yeah, you didn't hear my question, so that's perfectly fine. The idea was if we talked about the theory on the API permissions, on service principals, and enterprise applications. So. If you can primarily also show the portal, the Azure AD portal, and show where things are configured in there.
Okay, Joe. Should be seeing now this slide first, just to set up a few terms here. So we saw that we have token-based access to the API. You need an access token. There are different authentication flows, as they are called, or two authentication flows to get these tokens to authenticate with Microsoft 365, essential with AD, Azure AD. And now we want to have a look at how these permissions are configured. Permissions are not configured directly to the user, but permissions are configured in what they call it applications or application registrations. So permissions are granted to an application object, which is created in the portal, in the Azure portal, as app registration. This application object is the definition of an application. We will have a look shortly when I'm opening the browser then. But this application object simply lists the permissions which are needed or which are granted to this application once you are logged in and connect to this application. From this, and then you are requesting or getting a token for this application using your credentials. And this token then is able to contact Azure, Microsoft 365, and then using the permissions which have been granted or assigned to this application object for which you made the request, for which you used to get the token. We will see then that these permissions might be some very powerful permissions for which the administrator of the tenant need to give his consent. So not only a configuration of the application object, but simply an administrator then must give consent that this application, if a token which has been issued by Azure AD in relation to this application is able to execute and to make use of a certain API calls which need permissions, which need administrative permissions. If anybody in your these permissions then are granted by the administrator to the whole tenant. So it's on a tenant level. And we will see then a way to restrict this application connection then to certain users or user groups, so that not anybody in your tenant who figures out how to connect to an application, to this application, for example, by getting the application ID via other means, is then able to use it. But Azure AD would check the credentials of the user trying to connect to this application if it's included in the list of allowed users or allowed groups which might be connected to this application. Because the default, all authenticated users then may may use your application. So just let me switch back and share my browser. Which is connected to Azure AD or to the Azure portal.
Perfect. We'll see it now.
But I don't see it now. Now I'm seeing it as well. Okay, so this is the portal here, and we are dealing now with application registrations and service principals, and this is done in the Azure Active Directory. So we move to the Azure Active Directory. First, we have to define our application, assign the rights to this application, which is needed by our app then, which makes use of this application, which we define now, to get the information from Microsoft 365. So first we have to do our app registration. These are some apps which have been registered here in this tenant, and we'll open this admin app 2 because it needs it has some permissions then which need admin consent. That's the overview here, the application ID, which is needed when you are requesting a token, then the directory, the tenant ID, all this stuff. But here in the API permissions, you specify which permissions on which APIs does this application has. So anybody who then connects to Azure AD, gets a token connected to this application, would be able to execute the following permissions, or would be able to execute API calls which need the following permissions on these APIs. So here, for example, in the Microsoft Graph API, we have the permission group read, write, all. So once I have this permission, or once the application has this permission, and I'm as a user able to use this application, I would be able to execute all API calls which need a permission group read, write, all. And since this is really powerful, the administrator needs to give consent. So here, yes, admin consent required. The administrator need to give consent. So not only the application administrator, which is a role here in Azure AD, after constructing or defining this application here, will make sure that you can connect to it, but no, the administrator need to give his consent, grant admin consent for the whole directory, for the default directory, and then this green check mark here will appear, and then you will have the right to execute this API with this permission here. But the word is here, grant admin consent for the default directory, and this is done consented for everyone in your default directory, in your default tenant. So once this person or the persons would figure out how to use your application client ID on the tenant to authenticate, then to make a connection or to get a token from this application here, it would be possible to use the token with the API, and the API would have then to the permission group read write all on the whole tenant. So we need to restrict somehow where who is able to get a token actually from this application to use this powerful token then afterwards. So we will go back and now create what's called a service principal or an enterprise application. The same thing appears here. So our application registration is a blueprint. Is the definition of an application, and here we now define the service principles, more detailed specifications for this tenant here for this application. So the application appears, which we have created here. We're going in there. And then you see you can assign users and group provisioning accounts and so on. What we can see here in the properties for this service principal is user assignment required, yes or no? And the default is no. So every user which knows this application ID requests a token for it, and which is a part of your tenant here, will get a token then with the assigned permissions. Once you define or switch over to user assignment required, yes, then you can specify which users actually are allowed to use this application to get a token for this application or from this application. And this is done then by simply switching user assignment required, yes, and by going to users and groups and adding users from your tenant or others to be a part of the group here, which is allowed to connect to our application and actually get the token which contains these powerful permissions. So then can you simply add users from your directory here and add more users or groups. For adding groups, user groups, you need enterprise tenant. This is not an enterprise tenant. It is one of these dev tenants here. So I'm only able to add users and not groups. But in a real tenant, then, which is used in production, I guess, then you would have this chance to add a user group then and maintain the members of the user group at another place. So this is simply the way to restrict, to define which permissions on which APIs an application has, which then is used to issue a token. And second, to restrict the user accounts which are able to use this application to get a token. Well,
okay,
that was the short demo here.
Yes, very good. Thank you. So I will take back presentation control now. All right, let me just see if I can show my screen. There is so we've covered most of the questions here we had in the beginning, and talked also a bit like especially on the security level, because while doing development at NiCE a lot, we have various customers that use our applications, and in support we get often questions around this topic, and we see that many companies and administrators are not that familiar with these concepts of application registrations and service principles, as we've just heard. And I found also this explanation from Siegfried very helpful now. So, and Now we tie a bit back as a last point before we come to the next topic about if we develop now this application that's used, the Graph API, a simple .NET application, or any of the other frameworks, if we would be interested in monitoring and bringing data back. So, and let me share my screen for that. Let's go back, and now I have to find the screen sharing button at the right place here. There we go. So, okay, and I'd like to have a slide first. No, we've covered that. So we talked about security, and yes, this is about Application Insight. So Application Insight is also a service on Microsoft 365, and this enables you to add instructions or instrumentation to your code, which then provides details and logs and writes them also to your subscription in Azure. So, and in Azure, this would be and we call this Application Insights service part, and this can then ingest various items, like for example logs or metrics. So in this case, we can go, for example, to the metric data, and we ingested performance data also for Office 365 in this case. So, and we can go to space again, like either for Teams or for let's pick also for the Exchange Online tenant, and see, for example, like our mail flow. We would be interested in. Let's see, we should have mail flow somewhere here. Latency, mailbox. Don't find it, so let's pick another one for now. We'll check the receive latency. And then the data comes in and is being displayed here. We can also group this in workbooks together, and workbooks then give also an overview on, for example, here, licenses or whatever data you have. Everything is based on queries, and the queries we can also see. This is what I mentioned in the beginning, the Custo query language. And I think, let me find it. Yeah, I had a problem with accessing the logs, so typically I would jump to the logs, but as you can see, it just stays entirely empty. So this pane, so there's a problem right now in this application. So it's a matter of the demo god, so we can't really show the queries right now, which was the last part which we planned here, but we have to skip this for now. And I think we're anyway over time already. So then with that, I will wrap up the session here, the Q&A session. So thanks a lot to Siegfried for taking the time today and presenting here. Also, Mugove, thank you to you. So we're here on the agenda and coming down to the last part at 10:15 and cutting down the Azure costs. So like we have seen, if you used a lot of these services and subscriptions, we've shown you on Azure, this incurs in costs. So, and Samir, who's on there. Samir is from a company called Squared Up, who works with develops some dashboards, and they will give us some information, give us some more detailed information in a moment. This is similar to what I showed in the very beginning for the agenda item number 1, where I talked about this importance of service monitoring in times of COVID-19. I showed an overview dashboard of monitoring Microsoft 365 services. As we from NiCE here provide the data into the system, Samir is more on the visual graphic front end. So, and Samir, I think you started already, so please go ahead and start. And I will be back with some questions if I may, Samir. I hope that's okay.
Sure, of course. Thanks,
Okay.
Thanks, Christian. Cool. Hi, everyone. So my name is Samir, and I'm one of the technical evangelists and solutions engineer here at Squared Up. So we are here to talk all about the evergreen topic, I guess, of Azure costs and how you can manage it. Instead of just boring you with what you should do and should not do to manage your costs, I'm actually here to tell you what we did at Squared Up to actually take control of our Azure costs. A little bit about Squared Up, if you haven't heard about us already. We are quite simply, we help you build awesome dashboards We've been doing it for Scrum for a long time. I think it's about a decade now, and now we're also doing it for Azure since about a year or so. We are headquartered in the UK, but we have customer base around the world, more than 600 customers, pretty much everywhere in the world, and also 3 office locations to cover all the time zones. I think it's safe to say that we are loved by our customers. With the numbers to back it up, with a renewal rate of 95%, maybe the CSAT of 98, or of course our big brands that you're seeing here in the logos. Right, so let's talk about the topic at hand today. So what did we do to reduce our Azure costs? Before answering that, though, let's take a quick look at what we're using Azure for in our company. So at SquareUp, we use Azure quite extensively. We use it to run our internal applications, development tools, test environments, automation, demo systems, and the list goes on. Over time, actually, so as the Azure gets even more mature, and with all the nice new developments in Azure space, we are leaning towards Azure even more. So we use a variety of Azure services now, which includes, of course, the virtual machines, app services, logic apps, Azure Monitor, all that good stuff. But of course, as they say, with great power comes great responsibility. And you can see with all the good stuff, we were pretty much starting to incur a lot of costs pretty quickly. In early stages, when our Azure use was fairly limited, we weren't much concerned about the cost aspect. But as our company is going through a rapid expansion, both in terms of size and product catalog, so we started relying more on Azure, and this cost started to rise pretty significantly, as is evident from the screenshot here. Up to the point, actually, that our finance department was now getting concerned and actually flagging those costs as a rapidly growing expense, which eventually became, crossed all our software expense at one point. So of course, the first place we looked at was Azure Cost Management, which is where this screenshot is from. So you can see from the Azure chart here, the growing trend, and as you can imagine, it was not looking good. While this chart tells you the money that you're spending at something, but what it doesn't tell you is 3 things. So 1, if those resources are actually being used. 2, if yes, then by whom? And 3, do they really justify the cost against its use? So the third point is actually pretty key here in this discussion, which will be the theme of all this presentation that I'm showing here, because it's not as simple as if you see something costly, you just turn it off. It may be an actual useful resource that is being used by everyone, is being used for development or something. The theme here is whether the cost of that resource is justified in terms of performance. So we are combining the performance aspect with the cost aspect. Excuse me. So as we started noticing the costs pretty much snowballing, we needed a plan to control the cost. But at the same time, we did not want to take away any of those awesome benefits that Azure provides you, like, say, instant access, the scalability of your resources, pretty much nothing to low overhead of maintenance, all that stuff. Right, so everything that makes your teams focus on their actual jobs than to just mess around with secondary tasks like maintenance, installations, troubleshooting, spinning stuff, all that stuff. Luckily, this problem coincided with the launch of our Azure product. So we just decided to take our own medicine, if you will, and came up with a rather simple 6-step strategy. So step 1 was to pretty much identify the quick wins. As you install SquareUp for Azure for first time, a handful of cost visualizations also come with it. including this very high-level tree map and the cost breakdown by Sunburst here on the right. So in the tree map, what you're seeing here is actually where is all the cost going, right? So these are individual resources that are actually, so these are color-coded. So if you hover on one of these resources, you will hover all the others, grouped by your choice. Maybe it may be grouped by resources. It may be grouped by the type of the service and so on. And on the right in the cost breakdown in the Sunburst, so these rings you see, these are concentric rings. They actually are tiered. So it means in the innermost ring represents a subscription. One outside of it represents a resource group, and the outermost ring there represents individual resources. So now we know if there is any particular subscription or a particular resource group or even a particular specific resource that is costing us all this money. Then we, took it a step further, and then using a trend graph, a line graph like this, so we identified, has this cost always been like this? Is this a fairly static cost, or has there been some unusual event maybe that has happened in the past that is causing this cost to basically snowball? And so from here, so we start talking about combining performance with the Azure costs. So one of the quick wins was to identify the zombie resources or underutilized resources and just either turn them off or at least downgrade them. Right. So not very surprisingly, a lot of cost was caused by the resources that are being, that are deployed by someone at some point, but no longer being used. So we took on to finding such zombie resources that were contributing pretty much little to nothing to the business, but still incurring a lot of cost. So as you can see in the dashboard here, we are going the other way around. So we are saying instead of showing me the top 5 highest CPU, show me the top 5 lowest CPUs. And the similar KPIs for the other sister, service types. And what this tells you is the resources that are underutilized or not used at all. So say, for example, in this first tile you're seeing here is a lot of resources is pretty much, hugging the 0 line there. So all those resources are still costing money, but they're not being used at all. So it is very easy to identify such resources and then just simply turn them off, maybe consolidate them into a single resource if you don't want all the individual, virtual machines and so on. Now, the second step was drilling in. So now that you've identified and acted upon some high-level quick wins, we started to look around a little more closely. So some costs are pretty straightforward. Say, like for a virtual machine, it costs you, a fixed rate per hour. But there are also some associated costs with it that are a little more hidden. So say something like the log analytics, or say like a logic app, or say like a static public IP. So all these are not actually apparent at the time of deploying your virtual machine, but they are still there. So we started drilling down into individual resources and trying to find out if there were any associated costs attached. And actually, more often than not, we realized that we could actually save a few bucks here and there with some minor tweaks to settings without having, without really affecting the performance at all. So say with an example of a log analytics workspace. So if this machine is sending data into logs, do I really need to be sending this? If this is a development or an internal virtual machine, do you still need to, pump all that data into log analytics? So it will not cost you in the cost of the virtual machine, but it will cost you as the data ingestion goes on into the workspace. The workspace starts costing you more. So the first 2 steps were to identify the big wins, and secondly, drilling down into individual resources. using by repeating these two steps a lot of time over a few days, we identified actually reasonable, considerable cost, and then we just turned down some machines, consolidated some machines that were not being used that much. So now that we identified all the saved cost, the next step was to keep it that way, right? So in step 3, we put in some automation in place to keep a check on resources not being used but still running unnecessarily. So the classic example is you put a schedule for virtual machines to turn it off when out of the office hours. So virtual machines that don't really need to be running 24/7. They just need to be running for say like 40 hours a week, which is your work routine, and then the rest of the time they can be off. But there's a little challenge about that. So people can't necessarily stick to one schedule, right? So like I mentioned before, we have locations in different time zones. So all the time zone wizardry comes into place here. So since we are headquartered in the UK, but we work even US times, we work India times, we work UK times, of course. So people work different times. So it is not actually feasible to have a hard set schedule for all the virtual machines, especially in nowadays when people are working from home. The office hours are, the definition of office hours is a little more foggy at this point. So to basically conquer that, what we did was since we use Slack a lot in our company internally, we simply created an integration using, say, like a Logic app that combines this with simple Slack command that you can type into Slack, and they will, act accordingly in the Azure portal. So you say here /start from VM /stop my VM. These are just a simple Slack commands using which, even if you are in office hour or outside of it, you can still operate your virtual machines remotely from there. Of course, we're taking this automation a little bit further. So VMs, of course, were the greatest cause of our expense, and I imagine would be the same for majority, if not all, of the other Azure estates, VMs. So the next thing we decided to standardize was tagging the owners to their VMs. We made a Logic app, basically, so that tagged all the newly created resources with their owner values. So if you see a resource a virtual machine that is running in Azure, is fairly highly capable, right? So it's fairly expensive also. But if there's no associated owner information with it, you don't know who to go to, right? So if this VM is actually being used, or what is it, deployed for a test or something, is somebody using this machine and who, right? So these are two important points to note when you are taking any action on a virtual machine. So instead of the classic like scream test, where you simply turn off something and then wait for somebody to shout, hey, why did you turn off my VM? So that's not often the most productive way of turning down things. So with tags, so we now had a name of the user or the name of the team that is actually deploying these resources. And once we have the names, you can reach out to the person individually and say, hey, are you using this VM? Please make sure to turn this off if you're not using blah, 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 right? This tagging also helped us further to do more automation, like deleting unused resources after a certain age, right? So a virtual machine, for example, if it is hasn't been logged in say like 15 days consecutively, then just destroy this machine. And so that kind of automation you can also do using tags. Oh, and another benefit of using the tagging was actually that in Squared Up, now you can scope your dashboards. to a particular tag or a set of tags, right? So now you can create dashboards which are like more team specific, so or a user specific for that matter. So you can have a dashboard that says, show me the cost of all my virtual machines in the playground subscription for example, and that is being used by the development team. Right, so using this set of tags, now you can create dashboards that are more specific, more focused on something, and it's identified to associate owners with the resources. The next step was to actually empower the teams themselves to keep their cost in check, without the managers having to breathe down their necks. So nobody wants to be micromanaged, I guess. So if somebody is keep nagging you, like, hey, don't use this, it's costing us a lot. Hey, don't use that, it's costing us a lot. So it can get irritating pretty quickly. So instead of that, what we decided was to give that power to the teams themselves. So whenever they're looking at their performance of their applications, their services, whatever is running in Azure, they should also be mindful of the costs that they're incurring. This, of course, does not mean that there were any restrictions on the users to deploy any resources. So if you wanted a high-power machine, feel free to deploy it. If you wanted to, deploy 5 SQL PaaS databases, feel free to deploy it. But at the same time, be mindful of what you're costing. Maybe just clean up after your, when your stuff is done, or just keep an eye on what you're spending. So what we did was we started putting cost tiles into the dashboards we used to monitor each of their main services, so that it can, again, coming back to tying the performance with the cost factor. So you can, again, there's some dashboards here that let you identify the underutilized and zombie resources. Next up, finally, so now all the actions done, I guess. So the last step was to put all the dashboards in the wallboard, spread awareness, so to say, so that every team is mindful of what they're spending without compromising the performance. Right, so we put these dashboards all over the office. We have a nice few big screens spread across the office where we put on all those individual dashboards beside their teams, so they can view the dashboards and act accordingly. Of course, in today's world, I guess people are not in office as much as they used to be. So instead of showing it in the office space itself, so we are now embedding it into a SharePoint website, and we are publishing it to individual teams. So there's still no excuse to not be mindful of your cost. After all these measures, I guess, so today the cost is a little more under control. So as you can see, the bars are starting to go down. If not go down, then at least stabilize at some point. And this is despite of our ever increasing Azure estate. And so particularly you will see the virtual machines have, the cost has gone down considerably there. And it is, again, like I said, more and more people are being onboarded into the company. There's more resources that we are spinning into Azure, but despite all that, we now have the cost in more control. I guess that was about it for the slides. Any questions before I move on to that demo quickly?
Well, there's this question here, so we don't have anything on the chat right now from a question. So one question is from my side is that we have many customers that are a service provider model or an MSP. Right. So is that also possible for them to use, or would they have a different kind of use case?
No, absolutely. So you can use it if you're an MSP, if you're a CSP. So we are completely, we're fully compatible with the Lighthouse capabilities. So you will be able to see whatever you have the access to see. So that is what happens in the classic CSP or MSP models, right? So you have a charge of a lot of different tenants. So in Square, we also let you scope by tenant level. So you can also scope by subscription level, resource group level, or tags, that stuff. So yeah, it's absolutely usable with MSP or USP CSP model.
Okay, great. Thanks. So yeah, curious on the demo, please.
I'm not sharing anything, am I?
No, currently you don't share anything.
Okay. Let me find the window real quick. Okay, do you see a browser?
Something is coming up. Yes, perfect. It's coming up.
Right. Maybe a little slow because of all the latency I have down here, but right. So this is the Azure portal. I'll open up a few dashboards so it does not take loading each and every time. Right. So once you have deployed SquareUp, there are, like I said, there are some out-of-the-box dashboard that come along with it. So this is our preview lab, so that we have a lot more dashboards here, of course, but you won't have all of these, but you can very easily create them. So as a part of those out-of-the-box dashboards, you also get a few cost dashboards. So this one's cost by overview, by tags, and by subscription. So as the name suggests, the overview dashboard is the cost overview of your entire Azure estate, right? So everything that you have in your tenant, or if you have an MSP, you can also have it scoped by tenant. So you can see all the cost in one place. Again, so it will take a while to load.
So let me quickly ask, like, the data you're collecting, is this coming from APIs or is it coming from the log analytics data store? Like, where is this data kind of retrieved from?
Yeah, so this data is retrieved from the cost management API in Azure. So it's the same API that the portal uses, actually. So all this data you're seeing here is the same. So it's coming from the same APIs.
Okay, so the APIs are directly basically triggered from when the board loads. So that means it's running them while the loading is done? Exactly. So whenever you click on a dashboard or say you refresh a dashboard, it will actually make those queries in the background. And it will fetch. So the reason it is taking quite a while to load is because it is evaluating each resources that are scoped into this tile and then making individual queries in the background and bringing back that data. So that's the reason it's taking a while. But what that makes sure is that the data that you're seeing here is always current. So this one, for example, is the cost overview of everything that you have. Again, a trend of the cost. So you can see it's fairly static over the period now, which is a good news. Again, the sunburst tile that I was talking about. So this one here, the innermost ring here is the subscription. This is the resource group, and these are individual resources under it. This tree, like I was saying, so if you hover on one of these, it will highlight the associated resources. So this can be grouped by a resource group, can be grouped by a service type, and so on. So this is the tag dashboard I was talking about. So all this tagging, so we can now actually scope the dashboards to a set of tags. So this here, for example, is the set of tags being assigned to the retail division. This is for the sales and so on.
And lastly, cost by subscription. So we've got 3 subscriptions here in our internal tenant, which is the public demo, commercial services, and internal. So you can see individual how much they are costing me. Again, with a very helpful sunburst here. The great thing about SquaredUp in general, not only cost types, but everywhere in the portal you can drill down. So remember the second step that we talked about. So it was drilling down. So you can now, you identified these resources. You can now click on this and it will take you to that actual resource in the background. It will tell you, will give you more information about the resource. Basically, this is not only cost, but it will also tell you about the performance. These are just some of the platform metrics that you get here. If you've got any alerts coming, on this resource in the background, and of course, the cost information. One thing you notice here is ServiceNow. So SquaredUp has this neat capability that you can bring in data from also external sources. So if this resource had any incidents or any changes that were open, active in your resource, in your any ITSM tool, so to say, not just ServiceNow, you can also bring them all together. So it acts as an excellent single pane of glass. Lastly, the last dashboard I wanted to talk about was this resource utilization. Again, going back to the theme of time performance with cost. So this dashboard is all about that. So these dashboards are actually tying a performance counter against the cost that particular resource is incurring, right? So in case of a virtual machine, I think the most important KPI that we judge a VM, whether it's being used or not, is the CPU mostly. There can be, of course, other things like IOPS, network bandwidth, storage space. But the most used, I think, would be the CPU. And so, okay, so I'll illustrate this by giving you an example of these 2 tiles here. So this one is a darker in color and also fairly big in size. This one again is fairly big in size, but it's lighter in the shade. So what this means is this dark, I don't know if you can see the number here. So the CPU average running on this machine is actually 99.27%. So what I can deduce is, okay, this machine is costing me 200 pounds, close to 200 pounds, but it is also being used to its max. But at the same time, this virtual machine is also costing me 200 pounds, but the CPU performance is actually 0%. So there's nobody using this VM. So then again, why am I spending 200 pounds on this machine, right? So you go on repeating exercise for all your resource types, service types, and then you, at the end of this exercise, you end up with a considerable sum of the savings that you cost. Again, going back to the drilling down, so clicking on everything will take you in the background to that individual resource. Here, this path is you can navigate through any of these levels right from this navigation bar. I think that's about it, Christian. That's all I wanted to say. Any questions?
Yeah, perfect. Yeah, I have another question. Like when you say when you deploy ServiceNow, what does it mean actually? SquaredUp, sorry, when you deploy SquaredUp. So what does it actually mean deploy a SquaredUp? So is this something where I have to set up a separate system for, or is this something you provide and to subscribe to? So maybe you can quickly talk about like what that would mean.
Yeah, sure, no worries. So when you deploy a SquaredUp, what you do essentially, so you have 2 ways of deploying SquaredUp. So you can either deploy it using Marketplace, or you can also download the EXE that you can then import on, copy on your virtual machine and then run it like that. So whichever method you choose, what it ends up doing in the background is basically it creates a virtual machine of the appropriate size. You can, of course, resize it later if you want it to be more powerful. So it creates a virtual machine, puts an instance of SquaredUp on it. And it's basically, after that point, it's just a website. So everything you see here is web-based, as you can see here on the top. So it's not quite SaaS, where you subscribe to us and we host it on our prem. It's actually you host it on your environment, so all your information is private to you.
Okay, perfect. So and last question maybe on the licensing. How is it licensed?
Yeah, so the licensing goes per named user. So what a named user is any user that needs to log into SquareUp or interact with SquareUp, consume data, say like drill down into resources, create dashboards, modify, manage dashboards. That would be a named user, but you don't have to be a named user to see SquareUp. So if whatever dashboards you have, say for example, this one is a cost dashboard. We have a feature called Open Access, which lets you view a dashboard without consuming a license, right? So if I have 10 users that actually need to be interacting with SquareUp, drilling down and troubleshooting and finding out more, all that stuff. But I say my manager is not really concerned about navigating into things into the Azure portals, not really concerned about the performance part of it. He just wants to see the dashboard. So using Open Access, you can share this unique link with the management or say your manager, whoever. This will render the actual image. So this image is static. So even if I click on this anywhere, I can't drill down into it. But the plus point of that is it does not take a license. So it is a read-only, view-only, consume-only kind of dashboard. Having said that, it is not static. The page might be static, but the information in it is always refreshed. By default, 60 seconds, but you can choose to set your own interval.
Wonderful, great. So yeah, thanks for this information. So right, I think with that, thank you very much, Samir. And I think we're coming to the end of this session. So and with that, I say thank you again and wish you a good rest of the day.